Sorry, 1 second. I'm here, but I have to hit send on an email real quick. I am here though. We're just starting in 1 second, but sorry, I have a student making my life difficult, so I need to see if I can get their issue settled. Okay, sorry. Let me take that down. Okay, hello everybody. Um, we are coming up on. So we're in the sort of getting down to the last stretch after this project 3. Um, so of your efforts, and thanks to those of you who were uh, so active in the course and made yourselves so helpful to your classmates on Discord and uh, in the chat here on video. I very much appreciate it, and whatever you guys are doing to support each other, that's just outstanding. So thank you for that. The email's not cooperating, so I will abandon that. Yes, we know. Okay, so the plan this week is to cut the lab in half and do a little bit of project, a little bit of lab, a little bit of project both days, just like we did last week. So let me bring up the browser view. So here's where we're at. I'm getting bad lag on the video. I hope that's not your experience. I don't know what's going on. Okay, so anyway, here's where we're at. We're in the week of April 28th, so the project is due. Remember, all the due dates now are the Sunday, so this will be due by Sunday, May 3rd, and then we'll start evaluating them hopefully on Monday, May 4th, and get those back to you. So we're in the last cycle, um, heading into the fourth project. Today we're doing maps, which is another sort of it's adding on to the whole sequence. We've been doing arrays, and we did slices. So maps is just another variation on that same theme of putting data in collections and managing data in collections. But you won't use maps on Project 3. You might find a place where you can use a map on Project 4. In my samples for Project 4, I will use a map because there's some places where it's fun to use them. So you'll see some maps come into play when I start working toward Project 4, which won't be until next week. Okay, so maps first, and then I will sort of continue with my sharing ideas with you for how you might go about doing Project 3 that we've been doing now. I think we've been doing it for 2 weeks, and now this is week number 3 that we've been working toward Project 3. So it is a challenging one. Probably for many of you, Project 3 will be the most challenging one all semester, and then you'll find the fourth project. You can either sort of make it more challenging for yourself, or you can kind of leverage the things you feel most comfortable with. All right, let me get rid of this browser and start attacking. Okay, so maps. The only difference between a map and an array is the way you access data. So in computer science terminology, Let me make that slightly bigger. We use the term key value pairs when we describe these collections we've been using. So arrays are key value pairs as an example. Today is April 28th. Where the keys are integers that go from 0 to the length of the array less 1. And values are whatever you need them to be. So for example, if we have numbers, so for the array numbers, the keys are integers that go from 0 to 4, and the values are integers, right? Array slices are also key value pairs. Keys are integers from 0 to the length of the slice less 1, and values are whatever you need them to be. We should say whatever you want or need them to be. Want or need them to be. So we can make a slice. We could call it temperatures. So keys are integers. From 0 to we don't know yet because we don't know how big this slice is going to be. That depends on how many things have been appended to it over time. And values are float 64. I ran off the edge of the screen. That's a bummer. Let me put that down here. There, I'm happier with that. Okay, so there's a slice, but the point is that they are key value pairs, and what we mean by that is that a key goes with a value. So numbers, the key 0 goes with the first integer value, the key 1 goes with the second integer value, and so on. In the temperature slice, the key 0 goes with the first float, the key 1 goes with the second float, and so on. So maps. Maps are key value pairs also. Keys are whatever you want or need them to be, and values are whatever you want, need them to be. So these are a lot more flexible because you define the key. So we could say, for example, hopefully I make this one correctly. If I make a mistake, someone correct me. So we could say weather by day, which we could say is a map of string float 64. So what we're saying here in map terminology is that the keys are going to be strings and the values are going to be float 64. So instead of the keys just always being integers, which if we want or need them to be, they can be, but we can make the keys be whatever we want, and then we can make the values be whatever we want also. So here I'm saying that weather by day is a key value collection, a map, where the key, how you access the data, is a string, and the data itself is a float. And then you'd put data in there like this. So I'd make a key, and I'd say Monday. I don't remember. It was hot. Oh, weather by day, so it was probably a temperature. Let's call it temperature by day. By day, and here it was something like 97 degrees here in southern Arizona. And maps are a little bit different in that the way that you add data to the map is you simply just add a key. So I just added that key value pair to the map by doing that. So now Monday is a key, 97 is the value, and I can actually print it that way. So if I want to say the temperature on Monday was, and then I'll put a float here, and then I will use my weather by day, and then I will key it to Monday, which is where I know I put the value for Monday was at that key. So that's how you'd go back. So this one created the key value pair. This one accessed the value at that key to print out the temperature for Monday. So some people like maps because it lets you kind of use words and special numbers and things for the keys, whereas arrays and slices, the keys are always 0, 1, 2, up to the length of the thing minus 1. So that's how maps work. You just have to remember that the key is not automatically an integer, and it doesn't automatically thus start at 0. The key can be any kind of data, and the value can be any kind of data. You don't append maps, you just key them at a new location. So that just created the Monday key with the value next to it, and then I use that same key to go back in after the fact and then access the data. So that would be the 97 that I put in my map at the key Monday. That's how maps work, and that's what the lab's about. So we're just going to go through a couple of examples in the form of the lab. So the purpose of the lab is just to give you the basic skills to create and manipulate maps. Don't get confused by things like these items. Some of these are here to just remind you that using maps doesn't mean arrays and slices go away. It's just another option. Oh, you're right. What did I put there? Yes, temperature by day. Temperature by day. Good catch. Thank you. Temperature by day. That doesn't make any sense what I did. Good catch. Thank you. Temperature by day. Yeah, I changed the map name to be temperature by day, so what I did would have been completely broken. Thank you. Hopefully I didn't make that too tiny. I think it's still okay. Okay, we'll be on the watch for that when I get into the lab. Okay, so when you see something in the lab, just sort of try to remind yourself what that is. We can use arrays and slices and maps all mixed together. So this is kind of what this is challenging you to do, is sort of see these things together. So that's just an array of strings of size 5. Items at 0 is apples, items at 1 is sandwiches, items at 2 is chips, items at 3 is beverages, items at 4 is cookies. But we won't worry about that until the problem tells us to. Okay, so number 1 here. So number 1 says use the make function to create a map with string keys and integer values. I'll show you where I'm getting this, by the way, my answers for it real quick, and someone catch me if I don't turn the browser off again. If you follow this maps link right here, it may have a make. Here's a make right here. And there's words next to it. So to create an empty map, use the built-in make, and then notice it says make a map with whatever key type you want and whatever value type you want. So that's where I'm getting that from. So I want to, does it tell me what to call it? To create a map, the map represents a shopping list of items and quantities. Well, it doesn't tell me what to name it, but I'm going to go a shopping list. I can use the make function, but in this case, all I have to do is make the map. The key type I want is to be string, so that'll be the name of the items will be the key, and then the value that goes with it will be integers. That'll be, in this case, the name of an item associated as a key associated with the number of that item to buy when you go shopping. So there's number 1, shopping list. It has a reminder here to pretty print, so when I do have a chance to print something, I will be mindful of that and try to make it look nice. Number two, so we know from weeks of this that every time we say a %V, that means I'm off the hook. These things are not in the right place. There we go. So I don't actually have to pretty print here. I can just dump the whole thing. But I am going to put a label in here so I can see it. So when it prints, I'll know that's it. But what we know from experience is that these %Vs tend to print out the entire thing. Now I have not put any keys or values in this list, so let's go run it real quick. And what should be the case is that I have an empty map, just like I might have an empty slice. I know I'm not using that. Oh, it's not going to let me because of all those things. Well, that's a bummer. I'm going to comment that out. And I'm going to comment the other things it's grousing about out also. I want it to shut up. Okay, I just want to see what this does. Okay, so there it is. It's an empty map. I have attached no keys with their associated values with them. So that's what I would expect. So now I'm going to bring items back because I assume that's coming up. Okay, so we also, hopefully you remember from experience that when you have a numbered like 3A, 3B, 3CD, these usually mean it's one loop with several activities inside of it. Use a range loop over items. Okay, so for item, the singular. So notice here when I range loop over something, I get a key value pair. So I get an integer key for each of these items in this array and the item name. So the key for an array is an integer, and in this array's case, the value is a string as I range over items. Now, why am I doing that? User range loop. To populate the map with user input, each string from items will be used as a key for the map. So I'm supposed to take this item from this array and turn it into a key for the map. So I'll remember that. 3b says declare an integer variable, which is how many, so that's some quantity that I'm supposed to have them type in. I will prompt for how many. Now I'm just going to be cutesy here, but if I want the word apples and then sandwiches and then chips to appear, well, I will plug those in from the range loop. So the item names I'm getting from the range loop, so why not use them to make my output look awesome? There's an example of pretty printing. So I declared an integer variable, I prompted for and read in a user value, and I actually plugged in the item names I'm getting from this array. Then I'm going to, oh, it says just put the user input right in the map. That's awesome. All right, let's, why would I do that? Oh no, okay, it doesn't. Prompt for and read in. So read in the quantity. Now, number D. So assign the user input to the map. So I have this map shopping list, and what I'm trying to do is create a new key value pair in here. The key is the same item string that I used in my output. So it'll be like apples and then sandwiches and then chips, and then the value will be the quantity they typed in for that item. So if they say I want 3 apples, this is going to say the shopping list at key apples is 3. That's how that will work. I know I'm not using this. Oh wait, what's it complaining about here? Well, I didn't use the I know that. Oh, well, that's a biggie. Forgot the colon equals up here. I'm not using the key part of the items, so I'm just going to ignore that part like we've been doing. I just used the item that I pulled from that array. So one thing to notice here, so why did I do this? The reason I did this is because if I loaded all the item names up in an array, it made it a lot easier to write code to populate the map. So I use the array, a looping through the array, to get the names that I then use to key into the map. So I did that because it's easier to program that way. And then a %v, so updated shopping list. What we hope to see now is the stuff that I typed in. And %v lets me off the hook for true pretty printing. Okay, so now I'm just going to put some, so 3 apples, 1 sandwich, 2 bags of chips, 4 beverages. I'm doing all different numbers just so it's easy. I'm gonna need a bunch of them cookies. And then here's my updated map, and you'll notice that it's got the key value pairs that I created. So here's my item, and then the quantity I typed in with that item, next item, quantity I typed in, next item, and you'll notice back up here that that same item word that I was using in the prompt is the same item word I'm using as the keys. So some people like maps because they think that they're kind of easy to read and understand. So instead of saying item at index 0 has 3, it says apples have 3, and that, to some people that makes a lot of sense. I can just see the word apples and I know immediately, oh, you wanted 3 apples, not 3 of item 0, whatever that is, which is an advantage of the map. Okay, so that's the basics, and it probably looks a lot easier when I do it, but anyway, that's that one. We're going to do 2 of these. Aren't there 4? There's 4, so we'll do 2, and then we'll talk about project 3 stuff a little bit. Okay. Yeah, string float map. Sorry about the moving up and down. Did I have some stuff in here that I commented? I did not. Okay. Use the make function to create a map with string keys and float values, which represents a list of months. So the months' names will be the keys, and the average rainfall will be the values. So I'll call that, I don't know, rainfall map equals make a map where the keys are strings and the values are float 64. It'll be empty initially, and this will prove it. So we'll just use this print to show that it's empty to start, which is why that's there. Real data, well, we're going to be making up the data, but I don't like using fake data in programs if I don't have to, so that's why links like that are there. Okay, enter the correct value for each month into the map. The month will be the key. The average precipitation will be the value. So there's no looping opportunity here. There's no way I can really loop this unless I create an array of the month names and then do something like I did in the prior problem. But this is here just to show you that you can manually populate a map if you want to. So this is the month, so I can just do this and put values. I don't know what these are, but I'm going to make some up. January's probably a pretty decent one. Let's say like 6.5 inches of rain in January. February, probably a little bit less. Let's say 5.3 inches of rain. February, March. I'm about to do some copy and paste work to make this go faster. So March, I'm going to put the values back here. Okay, so March, April, May, June, July, August, November, December. All right, March, April, May. Thank you. Oh, that's awesome. Thank you. This is so great. And these are probably the real values from Baby Doll too, so that much improves things. Thank you. This is so great. Months list, months list, months list, months list. There we go. And I'm going to update my map name so that to me it's easier to change my map's name to match baby dolls than to change all of hers. So anyway, notice what she did, and she's got the real data. So the keys, and every time that you access or sort of reference a key that doesn't exist, then it's created for you. It's like an automatic append to the map. So there's all the rainfall values, and as the values, and then the keys are the months that go with them. So some people think that that's, and arguably it is, that's a lot easier to read, right? I can just immediately see that, oh, the month of January has this much rainfall associated with it. If I weren't using string keys, this could look kind of weird. Okay, thank you for that. Very much appreciated. Okay, so it wants me down here on number 4 to use a range loop to display all of the months with their average precipitation in a formatted way. So right here's some pretty printing, average January rainfall. So what I have to notice here is that it wants me to print out the key and the value that goes with it. I don't know what's going on with this stupid Twitch. Seemed a little laggy. Alright, a range loop. So I just have to think to myself, if this were an array, I would get a pair, an integer value, a key value pair that's an integer and something else. In this case, I'm getting a key value pair that's a string and a float. So the way I do this, instead of I for an integer key, I'm actually going to say that the key that I'm going to get will be a month. And the value that I get will be the rain for that month as I range over the months list. So I'll get one at a time. I'll get each month, January, and the rain that goes with it, which is 4.86. And then the range loop will go to February as the month, and the rain will be 4.42. And then I can do an output that's a lot easier for me to understand. So average %S rainfall is %.2F inches, and then the %S I fill in with the month. That's the key that I got, so I can actually use the key to make pretty printing, and the rain that went with it as well. So that's the month and the rain that the range loop is giving me. Pretty neat. That's another thing that I really like about maps, by the way. The pretty printing is like a neat and easy thing to do with maps. Let's try it out. I'm just going to say 1, 2, 3, 4, 5. And then here's all the, thank you again, baby doll, for those numbers that made that so much easier. There's the original empty map, and then here's my range loop. And I want you to notice something, because this is designed this way on purpose. Like, holy moly, October came out first, followed by January, February, March, April, May. Then there's some weirdness between May and August, September and December, and then, so this often doesn't matter, but it is a thing to note. Maps don't store things in any order that you can predict. It'll make sure that your keys and values stay together, but in the overall collection, each individual pair of key and value might end up anywhere. So it's just a thing to be aware of. You don't necessarily use maps if you have to have things in a particular order. You use something else that will respect the order that you put them in. So that's important to stop and take note of. They're all over the place. But that's what maps do. They will take the keys and kind of make them appear all jumbled around. But the values that go with the keys always stay correct. So if we look at October, 1.42, it's still correct. January, 4.86. September, 0.42. So the key value pairs stay together. But once they go all together in the map, then the keys, they're all jumbled around the place. Hopefully that makes sense. So we're about to switch gears and return to where we left off with Project 3 ideas. So what I will do on Thursday is the second 2 parts of the lab. But technically, I just want you to know that maps are there, and it's just sort of helpful to think in terms of collections of information. And I will try to make use of a map in my sample. I'll probably make a game for project 4 because I will have fun with that. Okay, so we're going to switch gears. Hopefully I didn't go too fast. I'll hit pause for just a second or two. If you have a question, I'm going to sit here for about a minute and wait for questions. Okay, so hopefully that means we're okay to proceed. So let me bring up where I left off. Where did I do that? Project 3, April 21st. That seems April 23rd. What's this? Okay, that ain't it. Edit row. Fine. Okay, I think this is where I left off. So project 3. Just a reminder that what I have in main is a mess. This is just examples. It has an example of how to create the slices. If you're going to use slices, it has how I created slices to hold the calculations and the operations. It has examples of how I went displaying the row plus my function for doing that. If you missed those videos I did over the last 2 weeks, you can go through those videos. Most days we do something on project 3 over the last 2 weeks, I believe. And we did the display row over a couple of different days and made it better and better over time. We have the ability to edit rows. We did a function that lets us select which operation we want to perform on a given row. That stuff. So what I'm going to do now is, well, I did select operation. So I'm going to do an update row. Function now will be the thing that I do today. So how would I handle the updating problem? I'm going to put this, do I want to put this in a loop? Not yet. I'm not going to put it in a loop yet. Okay, so this thing right here is me updating the calculation, but it's not intelligent updating the calculated value because it only calculates the value for row 1 if row 1's operation is minimum. So I want to make that more intelligent. And here's how I would do it. So this is the updating the calculated values. So what I would do is I would just update each row in turn. And to do an update, what do I need? Well, I need the row, and I need to know the operation that I'm supposed to perform on it. So that's, I think, all I would need. I might want to put the number 1 in there so I can do a no, I don't need that. Never mind that. This can be completely silent. So anyway, to do an update, I'm going to pass in a slice, which is the row, so I have all the data to do calculations on, and then the operation, because that tells me which calculation to do, and then that's going to return for me a calculated result then I use to then overwrite the calculations for each row. So to do row 2, I would do the next calculated value over, and I would update row 2 based on what operation row 2 is using. This is how I would do it. So I'm going to go write this function, update. Takes a slice, takes a string representing the desired operation, and returns a float. It's going to complain a lot, but that's fine. Okay, so I'm going to go up here above main. So I'm going to have an update. It's going to take a row, any row, right? I don't want to write it for any specific row. I want any row, and any operation, which I will just call the op, short for operation. So one row, one operation. And it's going to return one float, which will be the result of applying an operation to a row. Okay, so you could do a switch or an if here. You could switch on the op in the case that it is AVG. So it's important to note here, how are the operation strings getting to be like AVG and stuff? It's because my function up here to select operation is making it be. So these are sort of codes inside of my program that tell me what operations to perform. So AVG, of course, will be mapped to average, min to minimum, max to maximum, sum, and then it's possible that I could have an empty operation. So down here in update, I'm going to check the operation code, basically, and then that will tell me what to do. So if I'm being told to do the average, then I will return find average on that row. That's it. Find average is going to be a function that takes a row, any row, returns a float, and then computes the average of the row there. We've computed averages of slices and arrays, so you have that code. And then I'll sort of go back in a second and I'll sort of trace the steps through the code. Alright, so that's in that case. In the case that it is min, then I will return find, what did I call it? Minimum value. Minimum value on that row. So I take this row and I pass it along to a function that actually does the calculation for me. So this update function doesn't actually calculate anything. All it does is it figures out which calculation to apply. That's all it does. Case max, I would return find a maximum value on that row. I don't have that function. Where I would, we have the sum. So these are all the possible values for the operation string on one row. Average, min, max, sum. So same thing, I will simply return the sum of that row. And then I should have a catch-all, a default, in which case I'll probably just return 0, just to be safe. So if I don't find an operation code that matches what I have, I didn't do the find sum function, then I'll just return 0. Find sum. Where I would compute the sum. Now it's going to complain a lot at me because I have unfinished stuff in here. So update, all that does is just sort of it's a place where I put the messy problem of figuring out which operation to apply and then applying it, is all it does. Um, but I would do that. I would do all of them. In fact, let's ooh, am I gonna regret what I'm about to do? Maybe. Maybe I will, maybe I won't. I'm gonna go grab my Project 3 starter code. Notes. So this is a Project 3 April 28.go. Okay, so this is the starter code, and I just wanted to get back to this place so you can kind of see a little bit better where things get plugged in. So the original starter code kind of tells you where to do things. So I'm going to clean up a little bit and just go sort of map some of my things back into the original starter code. I'm going to grab all my functions. Don't need clear screen. Grab all these functions, some of which are incomplete. My functions go here. I'm going to fold all this stuff just to get it the heck out of the way. Uh-oh. That seems weird. I don't know what happened. Whatever. It did some kind of funky behavior and now it's back again. Okay, anyway, I'm folding up all these functions because I want to just show you kind of how this thing is put together. Okay, so there's all my functions. I believe that's everything that I need for the whole program. The functions part. Now what I don't have is what we call user interface, which is the menus and the parts where the user kind of says what they want to have happen next. Okay, so this is the original starter code, and I just wanted to point out for you that this sort of imagines a certain flow of things. So creating the slices, that part's easy to do, right? So we could just make slices of float 64 that are 5 many long, and we can make a whole bunch of those. I'm going to do that fast because this part, hopefully you're long past this part, so you're being bored. So sorry if you're bored. Hopefully I catch up hopefully I get to something that is interesting to you soon. So the rows, and then I need the calculations. And remember, the rows kind of go across. Oh, did it? And did it just stop when that weird foldy thing happened, or did you have to quit or anything? To me, it just kind of just decided to stop doing it at a point and went back to normal. Very strange. Um, Free software, I guess. Okay, so I'm following along with the original starter code. Um, just to kind of show you how it's supposed to be pieced together. Create the slices. Um, For the rows, those are the data going across. The calculations go up and down, one calculation per row. The operations, one calculation per row. Main program loop, so that's a for loop. And all that other crud goes in there. So I'm going to start to make it easier for myself to see. So clear the screen. Display. So display row 1. Oh, I gotta give it the row number first. 1. Yeah, I guess that's roughly what happened to me. I had to like find. I unfolded one function and it was still all goofy, and then I finally found the one that made it burp, I guess. I don't know. Um, I mean, I like Atom, but I guess that kind of thing happens with free software. Happens with pay software too. Display row 1. The slice for row 1. The calculation, which is in my calculation slice at slot 0. The operation, which is in the operations at slice 0. And then I would do all these things. And notice how these are all in the for loop. Row 2. I'm going to forget these. I'm going to do these right now, or I will forget them. And then row 3, 4, 5. So I'm just following along with the script here, if you see. So it tells me to put the loop here, so I did. Tells me to clear the screen there, so I did. It tells me to display all the rows there, so I did. And I just keep going. So there's where the menu goes. That's your user interface. So select option 1 to do this, option 2 to do this. Then you act on the menu choice. So that's a switch on some, I'll just call it menu choice short term. But notice here that the switch, see how the switch starts and ends, and then you have like case 1 and whatever you do, and so on. And then at the very bottom, so this curly brace right here is the end of the for loop. You see the little blue underscores. That's after the switch. So notice the switch is done. So way down here at the very bottom of the loop is where I do all the updates. So update row 1, operations 0, and make sure that I update the calculated value with that. And then I do all the rows. So I wanted to put this together a little bit better just so you could see how the starter code kind of tells you, suggests how you might put this together in main. 1, won't be sloppy. 2, 3, 4, 5. Okay, so that's why all that stuff is there. So I haven't left you actually that much fun. You do sort of have to figure out how to make all the bits and pieces work. But I wanted to point out to you the reason why these calculations are updated at the very bottom is because different things can happen based on their menu choice. So one of the menu choices, for example, is to change data. So if they change the data, then you want to make sure that the calculations get updated to pick up the changed data. Another thing that can happen in this switch is that they can change the operation. They can say, oh, instead of doing the average for that row, now I want to see the minimum value. So they make that change, and then after that, you update the data so that it does a new calculation for that row, and so on. So there's clearing options, and after you clear, of course, you want to update the calculated values, and so on. So this is kind of this part right here is likely to be messy because you have to do a fair amount of work to make sure your user gives you the information you need to make the program do what they want. So that's how I would put it together. This is incomplete, but just so you can sort of see, that's how it's one way that I might have gone about putting the bigger program together. And I'm going to end up, my guess would be that I'd end up here with another 50 lines or so, so 200-ish lines of code. If yours is way more, don't worry about it. If it's less, don't worry about it. It just needs to do what it's supposed to do. Okay, I think that's what I have. The only other idea I have right now is to just hunt down a running version of this program that I have and show you my live one actually running. So that's what I'm going to do now, if I can find one. Let me see if I have one. Fun Funnel projects. No, that's not going to be it. Somewhere I have one. Where, I don't know. Go spreadsheet? Sheet? Let me see if this looks like the right thing. No, that ain't it. I don't know that I have a complete one. At least I don't know where it went. It's probably sitting on an older version of laptop. Didn't do that one in the spring. Thought I did that one in the fall, but I didn't keep the project. So I guess I don't have a completed one to show you right now unless you want to wait while I finish one. Anyway, hopefully that sort of gives you some sense of how I meant for Maine to be put together. There's a lot of stuff going on in Maine. By the way I put it together. And test. Of course, you need to, once you get it running, test. Oh, that'd be awesome. Would you? If you'd run yours, then I can show a running version. Actually, you know what? I have yours. If so, can I take this as permission to download it and show everybody? Because I have that. I'm pretty sure sitting in my inbox. Let me see. I guess please email. Yes. That would be great. And then I can just I'll fire hers up and I'll show everybody how that looks. So what we're doing is we're just pausing for a second. I'm going to get a completed one from one of your classmates, Baby Doll, and run it just so you can see the completed program. I'm not going to show you her code that she wrote, but I will show you what a correct running program looks like. Awesome, thank you. Okay, here we go. So this is one of your classmates is finished, and she's generously shared it since I lost my running version. Um, so let's watch hers in action so you can sort of see a finished one. I'm gonna put it up here and make it bigger to look at for a moment. Okay, so here we go. Got the 5 rows of data, so there's 5 data cells. The other thing to be on the lookout for here is that she may have done things differently than the way I did it exactly, and that's fine. What you want is a running program. So there's the 5 pieces of data. There's the calculated value for that row, and then here's the main menu. That's fine. Don't worry about the clear screen in this version. That actually might be helpful because we can scroll back up. So I think that's going to be just fine. So here's the main menu with an edit operation, changing the operation, clear one of the rows of data, and then clear all the rows or exit. So let's edit something. Row number 1, cell number 1, and I'll just put 1.1 in there. And then I think what she did is she detected that there was no operation currently, so she's going to make me pick one, which is fine. So I picked the sum operation. So now you can see that there's my row 1, cell 1. I now have the sum operation, and the sum is 1.1. So yeah, actually not having a clear screen is better in this case because it allows us to sort of easily scroll up and down and look at the last state of things. I'm going to go edit another value in, so I'll edit cell number 5, put 5.5. I'll stick with the sum. So now it's 7.7. So there's a whole bunch of choices that you have here. I'll just sort of point out one that she made, which is working quite nicely. So whenever you update a cell, her program asks you to update the operation. You don't have to make the flow be that way. You can make the flow be that when you edit a cell, you just edit a cell and then you're back to the menu, and it's a separate operation, which I'm going to do right now. I'm going to change the operation in row 1. So I'm going to change it to be the minimum value, not the minimum, let's go with the max, the maximum value. And then notice the update display shows me the current maximum value. So it's pretty sweet. I'm going to go ahead and clear it. So that's clear a row, so I'm going to clear row 1. And then now notice what her display does is if you don't have a currently selected operation, it just shows nothing there, which is a good choice. So this is a nice running version. It doesn't have the clear screen in it, but that's actually helpful for demonstration purposes that that's disabled, so that works good. But anyway, just so you can kind of see the program flow. All that stuff that's happening, whenever I select edit, this enter a row number, you got to do that, right? So you sort of have to think to yourself, if your user's running the program, how does this work? Well, they say edit. Edit what? So her next question from her program is, I need to know which row you want to edit. I'll edit row 3. The next question after that is, all right, we're in cell row 3. Which cell? I'll say cell 3. What value do you want to be there? I'll say 97.7. And then at the end of that sequence, she also asked me to go ahead and update the calculation. So I'm going to say the minimum this time. And then it cycles back around. Minimum is 0, that's correct, right? That's because the smallest value in there is 0. So anyway, that whole flow of prompting the user, they select something, you ask them for more information, you ask them for more information, you finally operate on it. That's stuff you got to work on to make this program run good. And then exit should just exit. Nice touch to have the exiting message. So thank you, Baby Doll, for saving. That was awesome. Since my working version is somewhere in a backup drive somewhere and I don't presently have it accessible, there's a nice version. I'm also glad because then you can see the slight differences that we all make as programmers when we choose how to make a program flow. And how you ask for your user for information and in what order, things like that. Okay, that's no. So the question is, do you have to update the operation after every edit of a cell? And you do not. No. That was her choice as the designer of that system to ask the user if they want to update their operation after each edit. You do not have to do that. You can just say which row, which cell, updated, done, and then it's a separate menu choice to go edit or alter the operation after that. So yeah, which is the most important thing, of course, is to make it work. And it takes some, I think it just work is how I would describe it. It takes a little bit of work to get to the point where you feel comfortable making your own decisions about that. So Baby Dolls is sort of reflects the fact that she's grown more comfortable enough that she's sort of making some choices of her own about how the program looks, which is really cool. So if you're not there, you will get there with practice to the point where, like, this is, I think, how I would rather have it work, and you just do it that way. So this is a good example. Okay, let me fix my screen back into the corner and then sort of open the floor. So that's all I got. So now I'll open for questions if anybody has any. Uh, Structs for lab 14. Let me open up lab 14. I'm going back toward the, okay, lab 14. Go code. Struct. Ooh, that one's one of the scary ones. Okay, so the struct part is up here on lab 14. Yes, that's true. So yeah, I'm going to go back and address that comment because that's true. So the way I did it in this last example, because I update the operations after every menu choice, so no matter what menu choice you made, I go ahead and update all the calculated values. So if if your menu choice was edit a cell and it went through the process of editing a cell, the calculated values are going to be it's kind of wasteful, you could say, because every row has to recalculate its value, even if you only edited this one cell on one row. But that's how I handled it here. Um, so whether or not you edited a cell, these are going to update all the calculations. But that is important. You want your calculations to reflect all the changes that you make at the time that you make them. So this is the way I did it, and there are plenty of other ways to do it. Okay, struct, the struct for lab 14. So I don't know if you want to look at this one specifically, um, but a struct is it's what we call a structure, but basically it's a place where you collect multiple fields of data, multiple variables. So the fields are name, which is a string, gravity, which is a float 64, mean temperature, which is a float 64, and number of moons, which is an integer. The thing that feels funny about this at first is that there's not var on any of them in a struct, so you don't use the keyword var. But this is how you set up a struct with multiple variables, or fields as we call them, inside of it. So I'm not sure if that addresses the question or not, but um, that's what that struct would look like implemented. I've lost track of what my screen probably shows. Okay, I think it shows everything. Well, let's do so the trick is to understand how structs work. So given, well, that one's a little bit scary to look at first. There's a variety of them. Let's do a one-off example. Um, let's do an example instead. This is going to be April 28.go. All right, so let's just make something up and talk about the. So I'm going to make yes, exactly. You have to learn how to use dot notation. Baby doll, you can correct me because I'm not super fresh on ghost structs at this very moment because I haven't prepped that and I write in lots of languages. So let me make something up. I will call it, uh, I'll call it animal struct. I'll give an animal a name. I will give an animal sound, like the cow says moo or something like that. So the real super sort of minimal basics is that you can make, I will say that a cow is an animal, and it's a little bit like a slice or a map, uh, a little bit. So I'm gonna give its name will be cow, and then its sound will be moo. And then here's what Baby Doll was talking about. We'll start with the just the easy version of this, which is the so the blank says blank, two strings, and then we'll say cow dot name. This is the dot notation she's talking about. So I use my cow animal, and to get the name field from inside the cow, I do cow dot name, and then to get the sound from cow, I do cow dot sound. So there's the dot notation she's talking about, the little dot in there, and she's correct. We call it dots, dot notation. Um, I can make another one. I can say I can make a duck, which can also be an animal, except for its name will be duck and its sound will be quack. And then I can say printf. I see a typo. Hold on. The blank says blank. Now I say duck dot name, so this one's name field, and duck dot sound. Yeah, I noticed that. It just seems to settle itself a little bit on in my view, so hopefully that's true. Um, so if I say cow dot sound here, I get the moo from the cow animal, but I don't. I want the quack from the duck animal, so I use duck dot sound. And then I'll show you one other trick that makes. So I'll say my barn is a slice of animal, so you can actually make slices of these things, and I can put the cow and the duck in my barn, and then I can loop through with the range loop. I can say the individual animal as I range over through the barn. And then I can use the, let me call this a B, A? I don't know. A. Don't need the I, didn't use it. So you can also put these structs in slices and arrays, and then when you range over them, you're getting a struct out, and then you use the dot on the struct instance you got. So this will first get the cow as the A and the cow sound, and then it will get the duck as the A and its name and sound. Pretty neat. The other thing you can do that you'll see in there is when you see yourself like repeating the same stuff over and over again, the blank says blank, the blank says blank, you can turn that into a function, and if you want to put something in front of a dot, then you can put like a prefix argument to a function. And then you can use this A on the prefix. Now in here, instead of all that stuff, I can say cow.speak, and cow becomes the animal that's used to pull the name and the sound. Pretty nifty. So I could do this here also, right? Duck.speak. And then down here I could say a.speak using the a from the range loop. So there's lots of little tricks you could do, and the one thing I wanted to show you, well, one is to give you a hint about what you're seeing in the lab, but also two, hopefully you notice that the code got less and less and less and prettier and prettier and prettier. Cow.speak is, it's nice to code that way because you have a sense of what's going to happen when you execute the program. So hopefully that gives you some sense of what you're looking at in Lab 14. But also, if you're starting on Lab 14, we can look at it tomorrow during Q&A. And I also, I saw your email. I just haven't had a chance to look through it yet. I didn't run this, by the way. So anyway, there's the little running. Cow says moo, duck says quack, cow says moo, duck says quack. It's super nice. It just kind of feels good to write neat, concise code that way. And also code that kind of reads. You can read it kind of almost like English a little bit. Is very helpful. So like, oh, I've got a bunch of animals speaking. Okay, so I'm going to sign off here in a second. I'll watch chat here in a little bit as I sort of bring my system down. But if you have questions, please join me in the morning at 10 a.m. when I do the Q&A stuff. Right now I'm working on a game in the, well, I call it Godot, but you'll see me working on the beginnings of a game that I'm learning how to use a tool, which is just the thing that I do to entertain myself and keep my skills sharp. So anyway, I will be here at 10 a.m. in the morning, and if I don't see you then I hopefully will see you at 2 p.m. on Thursday. That'll be the last time that we'll discuss any project stuff. I suspect that meeting will go pretty quick because we don't have much lab to work through, and we'll just be answering project questions if there are any. So have a good time in between now and then.